Okay, this is to quickly show you and take you through all the steps of finishing your experiment 2 write-up this morning, just to make sure you know exactly what to do for each step. We did a lot of it before the experiment, but we talked about in class, again, how you have to, your independent variable is what did you change? What did we change about our 2 rocks? Because they were identical to begin with. What did we measure to see if there was a difference in strength or hardness? What did we have to keep exactly the same so it didn't stuff it up and make it not fair anymore, the testing? So what did we have to keep exactly the same about the rocks, about the way we made them, about the way we tested them when we smashed them off the balcony? And your hypothesis, we've already gone through this, but basically whatever you've got in these 2 boxes has to be in your hypothesis. And it breaks down to this: if the independent variable IV is changed, how? So what did we change about those 2 rocks? I went home and did something to one rock and didn't do it to the other rock. What did I expose one rock to? If the independent variable is changed and you explain how I changed it, then the dependent variable, the thing we're measuring, will do what? So you have to explain to me here what we expect to see in the dependent variable, how it's going to change. Then for A level, you need to explain why you've predicted this. So the chemicals in the rocks, when you cook them and heat them or put them under pressure, remember when you're making a metamorphic rock, it causes the chemical bonds in that rock to rearrange and become harder, to lock together more closely. And because of that, we see in metamorphic rocks a big difference in how those rocks hold together and how strong they are. The other way you could explain this prediction is also by talking about specifically the differences that we see in metamorphic and sedimentary rocks, and the fact that this is an experiment that models the changes from a sedimentary rock to a metamorphic rock, and what the characteristic differences we see. So a sedimentary rock, what's its characteristics? In real life we see metamorphic rocks and they are a bit different from their sedimentary precursors, and you could explain your prediction based on those principles instead. Okay, let's go down here. Risk assessment was really easy. You just have to remember what we had to do. When we were making the rocks, I warned everyone that the plaster of Paris can hurt you if you have sensitive hands. As soon as it gets wet, it will heat up and it can dry out your skin if you get it on your hands. You absolutely cannot get it in your eyes or in your mouth, because it will react with the liquid that's in your eyes and mouth and cause an awful lot of problems, because it heats up and has a chemical reaction as it cements together. And of course, plaster of Paris is a powder, okay? So you need to make sure that you don't breathe it in, that you don't muck around with it and spread it around the room. We had the windows opened so that we had good ventilation. We didn't have the fans on. Now, apart from the plaster of Paris, we actually did a few other things. We made sure that, well, you know not to eat anything, but when you went and tested your rocks, we went and had to make sure that everyone was safe, because we were smashing rocks. We had to make sure that no one actually got hit on the head. We made sure that people didn't get anything in their eyes, different things like that. So there's quite a few risks there we had to manage. Write down on here the horrible worst case scenario thing that could have happened, the accident, and here the rules or regulations in place to help prevent that accident from happening. Okay, down to the diagram. Now, most of you were asked or given time to do this in class. If you can, what I would like you to do when you have time is to click on here like this, go enter, and I would like you to go up to insert drawing, and you have a beautiful little whiteboard here where you can add shapes, you can add lines, it can be scribble lines, it can be anything, and I just want you to draw the setup of the experiment. So basically show the balcony, show where the rock landed, show that we're all dropping them from the same height, all of that sort of stuff. Now do your diagram last, okay? try and do the rest first. Now, you had to cut and paste your table yesterday, and I was going to put in a graph for you guys to copy and paste, but I would actually like you to do this in class if you can. If you really can't, you can do it throughout the day, or you have until this evening to submit. Now, this is how we do a graph. You have to open up your own spreadsheet in Google Drive. So in Google Drive, you go New, Google Sheet, and you just have to cut and paste in that data from our write-up. Highlight it. Just highlight the dispersal range, not the hardness. It'll just make things too hard to do. So here I'm copying this. Go over to your spreadsheet, paste it in, and then all you have to do is highlight it again and go Insert Chart. Pick a nice little column graph here, go down, and there you go. Now, to add in the titles and everything, because you need titles if you want to get anything better than a C, go to Customization, under Title, put your chart title, go down here, under Axis, I want you to label your horizontal axis. So you click horizontal, and down here you can type in that title. Change that to left vertical axis. You can type in your left vertical axis title. And once you've done that, go Insert. And in order to copy and paste it into your Google document, change the view mode to the eye. And then you can go here, right click. Somehow, I know you can go copy. If you go, look, Command C, I'll try Command C. Command C. Here, sorry guys, this one. Arrow, copy, go back here, paste. It is that simple, okay? So, just remember to add in your titles and you're done. We worked on our discussion and our conclusion questions yesterday, but I'm going to go through them one more time for you. Here you need to, this is a C level. How did you change your independent variable? How did I change what happened to my uncooked rock and my cooked rock? What did I change to make them cooked and uncooked? Then this is C to A level here. Did changing have any effect on the strength or the hardness of the rock? Describe these differences using your data. That is the C level part of that question. So go back up to here and look at your data and say, yes, there was a difference, and describe to me using the numbers that I've given you the difference between those two sets of groups. Then for A level, you have to compare them using ratios or multiples in order to paint a better picture. So I wouldn't just say it was 282 and 1 meter. I would actually go a little bit further and say how much bigger or smaller they are in terms of ratios and multiples. Question 3 is the A level question here. Discuss how this models sedimentary and metamorphic rock. Okay, you have to try and explain this to me. You have to tell me, how does this model sedimentary turning into metamorphic rock? Why is there a difference between the strength of the sedimentary, the uncooked, and the strength of the metamorphic, the cooked? Why? In terms of the ways they bond, the chemical reaction that's occurred when I've cooked them. You need to try and explain that as best you can in your own words. If you go back to our Metamorphic Rocks video, it actually has a very good explanation in there. You need to have talked about that. I can't actually give you much more than that because A-level kids need to go and remember that information or go look back in their notes themselves. I cannot give you a lot of help with that question. Lastly, this is just summing up the experiment. Was your hypothesis correct? Yes or no? And tell me why. Don't just go, yep. I want to know, yes, because in the data we can see blah, blah, blah. And I want you to tell me why your hypothesis was correct. Okay, so now I've explained everything we've pretty much already done in classes, but I'd like you to improve upon. The last thing we didn't do yesterday was evaluation of the experiment. In this case, you're just talking about whether or not we set this up as a fair test and how we could make it better, or how, if we didn't do it properly, how it would have affected and stuffed up our data, essentially. So the first question is, would this experiment be classed as a fair test? So do you think that we fairly controlled it? And if so, why? Did we control all those variables we said we needed to? And did we measure them as accurately as we could? Number 2, did the class complete each step the same way and control variables? So all of the groups, did we all do it the same way? Or was there a little bit of difference there between the different groups because people tended to do things their own way? Talk about that. Then say, here it says, how could not controlling your variables have affected your data? So if not all of our variables were controlled beautifully, so we didn't control perfectly how the rocks were exactly the same size and exactly the same amount and made of exactly the same stuff. Not everyone dropped them from exactly the same height, but we were pretty close. Not everyone measured exactly the same way. We had 3 different classes all measuring. So think about it. If we didn't control it well, how would that have affected our data? What would we see? 4, were your measurements as accurate as possible? You think between all 3 classes, did we all measure really accurately? And if not, how would this have affected our data? It's actually really simple questions to answer, guys, here. It's quite easy to do well in an evaluation. You just have to show that you're thinking about whether you've got good quality data or whether it needs to be improved upon. Now, the last thing here is proving you really understand that. How would you improve the method or how people measure things? So how people made the rocks, cooked the rocks, or threw the rocks off the balcony, or measured the rocks more accurately? How could we have improved upon that stuff in order to make this a really, really fair test? That pretty much sums it all up. Have a great day. I'll see you later.